Take a look at example 2. So in this example, it says that the curve has two stationary points. So the moment when we see stationary point, we know that dy dx is equals to 0. So part 1, they say show dy dx. So based on this y equation, I can now do my differentiation. And in order to do this, I just do my basic integration, differentiation. And once I get to here, this is actually the answer, but because they want it in factorized form, so I will have to factorize and I'll put show. Now part 2, find the coordinates of the stationary points. So they're asking for coordinates. We know that coordinates means your answer must look like bracket x comma y. So at stationary point, this is an important statement that you need to start with. Dy dx is 0. So I will equate my dy dx to 0 and I will be able to solve for 2x value. Once I have this, I will sub x equals to 2 into my y, which is here, and I will get y equals to 0. I will do the same thing for the other value of x, and I'll get y equals to 1. So with that, I'll be able to get my two pairs of coordinates. So this is my part 2. Now in part 3, they are actually looking for nature of stationary point. So what do we understand by nature of stationary point? So if we recall, nature of stationary point means it can be minimum, it can be maximum point, or it can be point of inflection. But how are we going to find out the nature? So for this example, we're going to use this method called the first derivative test. So in the first derivative test, right, this is what we do. We will start by drawing a table. And in this table, you will have x, dy dx, shape of dy dx, and of course finally graph. So how we're going to go about doing this is that we will start, since there are two stationary point, we will have to have two tables. So for the first stationary point, I will draw my first table. Since the stationary point happened at x equals to 2, I will put the 2 in the middle. And to the left of it, it will be a value slightly less than 2. And to the right of it, it will be a value slightly more than 2. So it's like a number line, smaller number on the left side. Okay? Then the second row is about dy dx. So what do I mean by dy dx? Now, if you look at it, your dy dx in this question is 6 bracket x minus 2 and x minus 1. So what we're going to do is that we're going to substitute in x equals to 2 into my dy dx. You will realize that you will get 0. So therefore, you have 0. And the shape of a gradient of 0 means horizontal. So I'm just going to do a simple sketch here. Okay, so same thing, I'm going to repeat this for 1.9 and 2.1. So when I sub in 1.9 into my dy dx, I'll get 1.9 minus 2 and 1.9 minus 1. Now, I do not need to know the exact value. I just need to know whether is it positive or negative. So if you can see from here, I will get a negative answer. So with a negative answer, I will just put negative. Okay? So with a negative gradient, it means that the gradient must be sloping downwards. So therefore, it will be like that. And then now I'm going to repeat this again for 2.1. So for those of you who can see the pattern here, we know that when we sub in 2.1, okay, when I sub in 2.1, this value here will be positive. This value here will also be positive. So we know that positive times positive will give me positive. So that's how I also can determine without calculating out the actual value. So with a positive dy dx, it means that my gradient will be sloping upwards. So if I were to combine these three sketch, the graph basically looks like this. And that gives me the conclusion that this is a minimum point. So with that, I can then say that 2, 0 is a minimum point. So this is what we call the first derivative test. And then why first derivative? Because we are making use of dy dx to determine the nature of the stationary point. So we're going to do the same thing because we have two stationary points. So we're going to draw another table, and then after that we are going to do the same thing as well. So in this table, okay, so now the focus is going to be on 1, 1. Okay, so x is 1, so I'm going to put x equals to 1 in the middle, and then choose a value slightly less than 1, choose a value slightly more than 1 on the right side. So with this, because this is a stationary point, we know that the gradient at stationary point will be 0, and hence the shape will be horizontal. So at x equals to 0.9, if I substitute it in, I know that this will end up negative. This will also end up negative. So because of that, negative multiplied by negative will be positive. So that's how I get my positive gradient. And positive gradient means it will go upwards. So do the same thing for 1.1. Okay, at 1.1, this value will be negative. This value here, when x is 1.1, will be positive. So negative times positive will give me negative answer. And with that, a gradient of negative will slope downwards. So with these three, I can now simply do a quick sketch of my graph, and it is a maximum. So hence, I can conclude that 1, 1 is a maximum point. So this is how we use first derivative test to determine the nature of the stationary point.